Good day everyone, welcome to CalcuMind, and today we'll be looking at sampling. So the whole basic idea of sampling, let's just take this idea. So you imagine you're an engineer in a company and the company tells you to get the length of each bolt. You don't just take the whole bolt that they measure in the company and decide to measure each of them individually. And let's assume that the company produces at least 1 million bolts. If you decide to take each of the bolts and measure them, it's going to be time consuming, stressful, and you're going to waste a lot of money. So the whole idea of sampling is from that 1 million bolts, let's say this is a tray, from that 1 million bolts, you're going to be taking out 10 of those bolts taking 10 of those bolts. You take out 10 and you're going to measure those 10 and take their average, which is going to be the sample mean. Sample mean is just like a big language. You're going to take in the average and dividing it through by 10. The answer that you're going to get is the mean length of the bolt. So now we can take this sample, can also take another sample and measure their length. Once we are done measuring their length, we can have like for here 3.86 and maybe this one 3.76. So now, once you have been able to do this, this is just the basic idea behind sampling. The process of selecting them and taking their mean is called sampling. And these 10 bolts are called samples. Now, we can see that this is 3.86 and 3.76. There is a variation that we can see, 0.1, minus 0.1 plus 0.1. This variation, how do mathematicians account for them? This is what we are going to be looking forward in our next session. Okay, now we are going to be taking a sample problem whereby we are tasked to find a sample whereby the question states that suppose a bag contains 5 balls, 1, 2, 3, 4, 5. It's just like a ball and it has a number inscribed on it. Let's say 1, 2, 3, 4, and 5. And we are tasked to find a sample with replacement, and we're also tasked to find another sample without replacement. So now the idea with replacement is that once you take out the ball from the bag, you're going to replace it. And without replacement is that once you take out the ball from the bag, you're not going to replace it. So now let's write out the first sample with replacement. Just note that the idea behind sampling is that the order of selection is random. So now, let's say we are going to take out 2 randomly. This is 2. We have taken out 2. We'll then put the ball back into the bag and we'll then take out another ball. Let's say the ball we took out was 3. Any ball that you take out, you're going to write it out. So we are written it out, which is 3. So now we are going to take another sample. Let's note that, for example, now we took out 2. Again, we are going to write it out. So we are taking a sample of 3 balls from the 5 balls. So now we'll be looking at taking a sample without replacement, which means once we take a ball from the sample, we are going to set it aside separately. So we have taken out, let's say we took out 1. We have written it down. We are going to take out another ball, 3. We have written it down. And we're able to get 5. So now, if you look at the two samples, you can notice that 2 occurred twice, and there's no recurring number from this sample. The whole idea with replacement and without replacement is that with replacement, a number can occur twice. 2 occurs twice here, and no number reoccurs without replacement. So that is basically the idea of with replacement and without replacement. So we'll be looking at this key terminology in sampling, whereby we'll be tasked to find the total possible sample outcome. So which means is the total, if you're to take a sample with or without replacement, the total possible outcome that you're able to get from those samples, that is what we'll be tasked to find. So with replacement, the whole idea is using n raised to the power of r. So n is the total number of, we have 5, let's assume these are balls. We have 5 balls and we are tasked to find 3 possible samples. So R is the number of samples. So N is the total items we are taking a selection from. While R is the number of samples. So now we are tasked to take 3 samples from these 5 balls. So our number of sample is 5. And R is the number of samples we are taking. So this is 3. So which is 5 times 5 times 5. So this is 25 times 5, which is 125. So if you do with replacement, you have 125 total possible samples. So let's look at without replacement. So without replacement, the whole idea is using a combination principle, whereby N combination R will give you the total number of samples present in the equation. So the idea for sample is N factorial divided by N minus R factorial. So I earlier stated that N is the total items we are taking a selection from. R is the number of samples that we need. So this is 5 factorial divided by 5 minus 3 factorial. So if you're not conversant with the idea of factorial simply means, if you have 3 factorial, it simply means 3 times 2 times 1. If you have 5 factorials, 5 times 4 times 3 times 2 times 1. So that is the basic idea behind factorial. So we'll be taking this out. This is 5 factorial is 5 factorial divided by 2 factorial times 3 factorial. So we'll be breaking this out. This 5 times 4 times 3 factorial divided by 2 factorial times 3 factorial. So this 3 factorial is going to cancel this out. It's going to also cancel this out. So 2 factorial simply means 2 times 1. So 5 times 4 is 20. 20 divided by 2 is 10. So we have 10 total possible sample outcome without replacements. I hope you have gotten this idea. If you enjoy our content, make sure to hit the subscribe button and like the video. Okay, now we are presented with a past question which states that the service lifetime of 10 prototype industrial machines bearing designs for heavy-duty engineering application are recorded as follows. 10, 15, the numbers are indicated on the board. So they say we should construct all possible samples of size 2, which means that the sample should consist of only 2 numbers with replacement and also without replacement. So first, the idea now is that we need a sample of just randomly choosing 2 numbers. So first, we'll use the formula N over R to find the total possible outcome in which I referenced before. So N is how many numbers that is here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 numbers that is present in this sample. And they say the sample should be of size 2. So R should be 2. So the total possible outcome is 10 raised to power 2, which is equal to 100. That is with replacement. And without replacement, we'll be using a combination. So N is 10 and R is 2. So they say we should construct the sample size. So this is 10, 15. We'll write out our first sample. 10, 15. I'm just showing you how, if you're to write out all, there are 100 problems. Because of this video, we won't be able to write out the whole 100 problems, but I'm going to show you how to do it. So this is 10, 15, 10, 25, 10, 30, 10, 45. You keep going on and on and on. 10 to 105, 15, 25, 15, 30, 15, 45. Why is that so? Because anytime you remove a ball, you also put it back. So now we'll be constructing the total sample outcomes without replacement. I told you earlier that we are going to be using a combination principle. So this is NCR is we are finding the total possible outcome, whereby n is 10 and the sample size is 2. So 10 factorial divided by 10 minus 2 factorial. So let's work it out. 10 factorial is 10 times 9 times 8 factorial divided by 8 factorial times 2 times 1 factorial. This 8 factorial is going to cancel this out. This 2 is going to cancel the 5. So this 5, 8 cancel this. So this 5 times 9, 5 times 9 is 45. So we have 45 total sample outcome without replacement. So now we are going to be writing out the whole possible samples outcome. So this is 10, and we need a sample of size 2, which is just 2 numbers in the whole sample. So this is 10 and 15. We are going to put it in this sample since there are 2 numbers. 10 and 25 in the same, just over here. 10 and 30, we'll do the same thing. Or we are going to be doing it for the entirety of the whole sample. So now this is 10, 45, 10, 50, 10, 25. Once we are done with 10, we are going to be discarding it. We'll do 15, 25. We'll do 15, 30. We'll do 15, 45. We'll do 15, 15, 15 all the way to 105. We are now going to be discarding 15, which means without replacement. Once we are done with 15, we are going to set it aside and we are not going to be using it. So we'll move over to 30. We'll move over to 25. We'll do 25, 30, 25, 45, 25 all the way down to 105. We are done with 25. We'll then be discarding all the numbers down here. So we'll do 30, 45, 30, 50, all the way to 105. And we'll discard all the numbers down from 30. We'll then move over to 45 and do the same thing all the way to 80. So now, at this point of 80, we'll do 80 and discard all the numbers beyond 80. So this is 80 and 105. This is where our equation stops. This is where our whole setting stops. And the whole total sample size is going to equal out 45 samples. If you do that, you are going to definitely get a 45 sample. Mean, variance, and unbiased estimators of samples. So the basic idea behind the mean, I'll be showing you 2 methods to look for the mean, which is the population mean and the sample, using the population mean and the sample mean. So using the population mean, we are going to be summing up 10 plus 25 plus 30 plus 45 plus 50 plus 65 plus 75 all divided by the total number. We have 10 numbers over here. So if you do the addition, it's going to be giving you 500 divided by 10, which is equal to 50. So now we have been able to get the mean using the population, the total population. Another method is using the whole sample. Earlier in the question, they say without replacement, and we wrote out the whole sample size without replacement, which gave us 45 samples. So using without replacement, we have 10, 15, 10, 25. So once we have written all the samples without replacement, we're going to add them up and divide them by the total number of samples, which is 45. So once we have this 10, 15, 10, 45, this is 25 divided by 2 is going to be giving us 12.5. And we have 10 divided by 25 is going to be 35 divided by 2 is 17.5. So using the total samples that we were able to write out in our previous video, you're going to sum all the whole samples up, the whole 45 samples up, and divide them by 45. We have already done that, but due to space and time, we won't be able to include that. If you sum that up, it's going to be giving you 225, and you're going to be dividing it by 45. is going to be giving you 50. So now we'll be finding the variance of the whole sample size. You remember in our earlier videos, we wrote out the whole samples. So now, using the population variance, this is how to calculate the population variance. This is going to be 10, 25, 45, 10, 30, 45. So now we are going to be subtracting it from the mean. The mean we have gotten it to be, this is 10 minus 50 is minus 14. 25 minus 15 is minus 15, is minus 25 rather. This is minus 20 minus 5. Once we have done that for the whole equation, we are going to sum them up. You're going to be doing 25 minus 50, 30 minus 50, 45 minus 50, 105 minus 50, all the way down to 105. So this is minus x. So now you're going to square this. This is you're squaring the deviation. So this minus 14, if you square it, it's going to give you 1,600. Once you're done with that, it's going to give you a total figure, which you're going to sum up. Once you sum up, that is the standard deviation, and you're going to be dividing it by the whole number. So that is how to find the population variance. We have already solved for that, and our population variance is what? We are now going to be dividing by R. Our R value is 2, which is the number of sample size we have been using. So we have two numbers, 10 and 25, which are two numbers. So our N is what? And N, the small n, all divided by 10 minus 1. So if you work this out, it's going to be giving us what? 384.44. So this is the variance of the whole sample without replacement. So now we are tasked to find the unbiased estimator, which is the next. We should decide whether the population mean is an unbiased estimator of the sample mean. This is just long sentences. What they are trying to say, is there any contradiction between the population mean and the sample mean? And if we have solved this out, whereby you add these whole samples, whereby without replacement, you sum them up, you get a total value, and you're going to be dividing it through by the sample size. You get a value which is 50. And this sample mean correspond with this population mean, which is 50 and 50. So therefore, the population mean is not an unbiased estimator of the sample mean. Thank you for watching the video. Make sure to like, share, and comment. And any question you have, leave it in the comment section, and hope you join our group to receive further updates on the videos we drop. Thank you.